everyone. Thank you for attending today's webinar, A Deeper Dive into Virtual Reality Technology for Smart Manufacturing. My name is Brittany, and I will be your moderator for today's webinar. Just as a reminder that if you experience audio difficulties, you can connect either by computer or phone. If you are interested, feel free to follow us on social media for updates and resources we are regularly sharing, as well as upcoming webinar information. Before we get started, I do have a few housekeeping items to point out. Everyone will be muted throughout this presentation. If you do have any questions, please use the chat feature to submit those, and we will answer them during the live Q&A at the end. Today's webinar is being recorded, so you'll have access to view this recording anytime you'd like at the conclusion of this presentation. Locate the settings gear in the upper left-hand corner in case you need to make any adjustments to those. With that being said, I would like to introduce today's presenter, Jeff Brum. Jeff focuses on establishing business relationships and completely understanding market and clients' interests and requirements to define unique solutions. Jeff's 11-year history with Mechdyne began as a senior marketing and global business development manager. Today, Jeff brings knowledge and technical resources to enable clients' business needs. Prior to Mechdyne, his work at virtual reality company Fake Space Systems ranged from product management and marketing to technical sales and sales support. Currently, Jeff develops and supports clients from Kitchener, Ontario, Canada, the head of Mechdyne's Global Technical Services Division. Now, without further ado, I will get things turned over to Jeff to get things started.
Hello, everyone, and thank you very much, Brittany, for that introduction. And thank you, everyone, for joining in today. And I see that we still have people joining, but we're going to press on because we have a full agenda. One of the things I would like to establish as we start the webinar is that, as the slide says, Mechdyne is vendor neutral. And how that's relevant to the webinar is that, as I say, we are a vendor neutral company. We are not tied to specific products or vendors for any of our solutions, and we are a provider of visualization and VR solutions. But really, we will source components from any supplier in order to meet a company's requirements for a specific solution and to help them achieve their goals. During this webinar, you may hear me refer to specific vendors, specific products, and really these are only for purposes of the discussion. These are not product recommendations unless I specifically say something, but really they are for reference and, again, for purposes of this discussion. So we'll go into the agenda overview and want to say that this agenda has been built on feedback we received from the original VR for Smart Manufacturing webinar that was done in May of this year. And that really was a high-level look at VR systems and things that we're going to be looking at today in much deeper detail. And I thank everyone. If there are people who were on that call and they've joined again today, thank you for that feedback. And as we dig deeper into each of these areas, these are things that were requested, and I believe we will get to the level of detail that you want. I would like to say, though, I am not a subject matter expert in all of the technical areas of these and products. We do have subject matter experts on staff in these areas. My role is to bring to bear those subject matter experts to achieve specific solutions. But I will touch on each one of these in the Q&A section. We're going to spend about 50 minutes on the webinar part, and we'll leave some time for Q&A, so please do submit your questions. And just want to say that if someone asks a question that I can't answer, I can make that connection to a subject matter expert if needed. So before we get started here, and I trust you can see that we have a small, very brief poll up, and asking how many of you on the call have a smart manufacturing initiative already underway, or I noticed that we have a mix of manufacturing organizations of all different sizes covering all different types of products, and we also have some universities and others on. But how many of you are already looking into smart manufacturing or have started some of these things? And the reason we ask the question is that it just gives me a sense of the knowledge that's out there. It also helps me with some of the things I've been reading about recently. Some recent research indicates that up to 77% of companies have not started a digital transformation or an Industry 4.0 initiative. So by looking at this, it just gives me some reference and also maybe shape some of the context of what I'm saying later on. So I'll give you a second to fill that out. I'm going to skip to the results. You should all be able to see it, and really there won't be any names. It's just a very high-level summary. So I'll give you another moment, and then I'm going to skip to the results of who has been polled so far. And we'll go now. So 38% have started, 61.3% have not started an initiative, which is good to know. And I think those who say they haven't started perhaps are doing this at an investigation level, and I think that's great because the webinar will provide that. Those who have started, perhaps you even have VR already to some extent in your organization, or are looking at other opportunities to extend your existing work. So with that, we will jump in. Something else I'd like to establish up front is that this conversation is about virtual reality, not augmented reality. I know there's a lot of talk about augmented reality out there in the marketplace right now, but they are two distinct things. Interestingly enough, I read an article yesterday where the writer was referring to augmented reality technology using the term virtual reality. So there was some confusion even on the writer's part, and I just want to clarify this. Augmented reality could be a discussion unto itself, an entire webinar, but again, we're not dealing with that. Augmented reality, and using this as a way to describe it, is a case where the world is your screen. You are overlaying digital information, whether it's text or 3D models, onto the real world. And you may be doing that for a variety of reasons. Person might be wearing the glasses of some kind and being fed instructions on how to assemble something. There might be a group of people or a single person wearing the glasses and viewing a 3D model to get a semi-immersive experience. Or someone could be monitoring equipment like these hydraulics or these turbines as shown in the picture, and with a tablet being able to see the status of all that equipment. But again, that is a separate technology. We are going to focus on virtual reality and want to take a second just to establish what we mean by that. Using the other reference, or the opposite of the other reference where I said the world is your screen, with VR the screen is your world. And that means that all of the virtual information is being presented to your eyes on a screen of some sort. The screen could be the lenses that are in a head-mounted display, or in the picture that's on the right-hand side, screens that are actually surrounding you, and information is projected or displayed on those screens, and the screens become your world. You're trying to simulate physical presence in that virtual environment, and trying to feel like you are present with the virtual model. And achieving that level of feeling like you're present comes from very many factors. The display fidelity, and by that I mean the resolution of the displays, the number of screens you have, how photorealistic things are factors in making you believe the model is real. The interaction fidelity is how easily can you interact with that model like you would in the real world. Can you move around it very easily? Can you pull things apart? Everything you do in the real world you want to be able to do in the virtual world. And there can be other cues like audio cues or even smell cues. Who knows what you're doing? But all these things can suspend disbelief and make you feel like you are present with that virtual object. So you're really trying to create a sensory experience to create a virtual world. Very quickly, current state of VR, because again, there's a lot of press out there about what's going on, and really all the press out there about head-mounted displays especially talk about, oh, this is great new technology, but VR has proven its value for more than 20 years. The picture on the right, was from 1998, but was referenced in an article this year. Head-mounted displays have been around for decades. Really what's happening is that everything is evolving. The displays, the computers, everything is improving. Everything is getting better and starting to meet the expectations of many of these applications, especially in manufacturing. And I mentioned AR before, and there's articles out there about AR coming on strong, and it's going to replace VR, but really I think there is a place for both technologies. Each one of them makes great use of your digital model, your digital twin, however you might refer to it. and just great ways to extend the use of your data. And then I think what you're going to be seeing is more application specialization. So training modules might be developed that are available off the shelf for training on specific assembly tasks of a sort, or training tasks of other kinds. And you'll see applications being developed for optimization of data, and some of that's occurring already. And where there's always been a focus on, but I think it's been increasing, especially in the last 5 years, is the focus in return on investment. And again, this is an investment, and we are being asked more and more, how can we justify investment in these technologies? How is it going to save us money or do other things? That is extremely important and is increasing in importance, because quite often these technologies are competing with other initiatives in an organization. So now you're seeing these are the elements of, I'm going to say, any VR solution, and really whether the display is a walk-in fully immersive display or a head-mounted display, the other elements remain the same. It's just the nature of those, the complexity of those will change depending upon the display you have, perhaps. And we're going to touch on all of these areas, and these icons I will use a little bit later as well. So the first part of this, and I don't want to spend a lot of time here because I think, again, each one of these could be a topic, and the types of displays are specific to different applications. But we were asked for a summary of the different display types that are available that go over and above head-mounted displays. So we'll spend some time on this. But first, I should spend a little bit of time on head-mounted displays because I think they are an important factor out there. They are, I mentioned they've been around for decades, but they are starting to meet expectations because of the increasing fidelity, just the way that people can view their data. It is a low-cost device. It's a great way to start trying things and to test things. You can deploy them at the desktop level. It doesn't require its own space. Resolution's improving. They started out as single user, but there's many multi-user applications where people can share in the virtual environment or share a virtual model, whether it's local or remote, and these devices continue to improve. But there are some considerations that actually can sometimes cause people to start with an HMD and then start to wonder what other displays are available. That might be a factor of the use time. People that have them often say they can wear them for maybe 15 minutes or 20 minutes, and then it just becomes too fatiguing, and for various reasons. People also feel cut off from the real world. You do have something mounted to your head. You don't have a sense of your own self. Even though you may have an avatar of yourself or your hands, things like gesturing are difficult. Maybe collaborating with others just doesn't feel natural. Or if you discover something, have an insight, you want to take some notes, even that can be awkward for some. So quite often we see people either using the head-mounted display as a viewpoint controller so that while they're looking at something, another group is connected or can see it on a larger display, a larger monitor or a power wall. And really that's where people see they start with something and then they move on to perhaps a larger display. And the next logical step might be something like a power wall. And in this instance, I'm saying a projected power wall because there's multiple ways to do these. But really, this is a familiar format because it's essentially a large desktop and gives you a good view, especially of CAD data where everything is linear and maybe you want to do measurements. And these, like a large desktop, can be used from 2D and 3D format. Important thing with these is that they are scalable. The image on the right, actually, I can remember doing this one. It was a 9-foot high by 26-foot wide sheet of glass with 3 projectors in behind, and it was done specifically to fit the facility requirements, but also it allowed that light armored vehicle model to be shown at 90% scale. And that scale was sufficient for the engineers to be able to make design reviews and design decisions and be confident in the decisions that they were making to be able to advance that model further. You can also build walls using panel technology. You can achieve higher resolutions. Panels are just that. They're very thin. You save a lot of space, but your computing requirements go up. So this is just one way to scale further. LCD technology can be used for tiled walls. You do get some seams, but direct view LED is coming on strong. It's completely seamless. It's completely scalable, but it is new technology. It's even 3D capable now, but it is new and it is more costly than the other technologies, so it's something to consider in your ROI calculation. Fully immersive spaces are just that. We're building an environment with surround screens. It could be a floor and a wall. It could be a floor and 2 walls, all the way up to 6 walls. The idea is to fill your field of view and make you feel, display things in one-to-one scale, and it gives you that sense of presence. Key thing with these is they're highly collaborative spaces. That shared perspective has a lot of value, and we'll get into an example later. You can extend this even further and make a reconfigurable space. You saw that image before and you think, well, that's limiting. That may not cover all of my use cases. So then you might consider a reconfigurable space, and I have a very, very brief video on the next slide that just shows that something like a cave could be built so that it extends out, stops, becomes an angled wall, and then could go out to a large wall. And think of it, whether it's, one example might be aerospace. And in a cave configuration, you're inside the fuselage and making decisions about where seats are going to be placed, and that interior design, push it out to a wall, and suddenly you're looking at the outside of the plane as a scale model, and you're able to work that way. It just extends the use, and higher utilization leads to better ROI. And these are the considerations. Multiple applications do lead to better ROI. So, while technology or while these things are scalable, they may require resources. When you get up to a large environment, then you are looking at potentially someone to look after that space. Computing increases. We're going to get into that later. You might have to make some facility modifications, so it becomes a higher investment. But again, you want to look at the return on investment, because that is the key thing to consider. The final part of displays, and we've been asked more and more about this, is can displays be made portable? And absolutely. When you go to a trade show, you see a lot of HMDs, but virtually every type of display that you've seen just before this can be made portable or transportable. You may have different reasons for doing that, for taking it out into the field, but absolutely there are many portable options available. So with that, we're going to move out of displays. And one of the questions we had was, well, I've noticed that some of them you've mentioned the term motion tracking, and really what does that mean? And it is as it sounds. You are tracking the motion of the person. If you look at the picture on the right, and this actually is going to be a video on the next slide, but you'll see that there's markers on the glasses, and there are cameras above that are monitoring that person's position, looking at their viewpoint orientation, their head position, their head orientation. The markers are also put onto the controllers that might allow them to navigate or interact with objects, and that just adds a whole other level of being able to work with your data naturally. This kind of motion tracking is integrated into head-mounted displays. If you've tried one, you would have experienced that already. But in a larger scale display, it's optional for everything really but caves. A cave experience really needs it, and you'll see this on the video when I start it. So you notice that as the person is walking in, you can see the car changing their viewpoint on it to the point where they're sitting down and actually sitting in the vehicle, moving around, and from there can start making decisions on, what's it like to look out the left window, the right window, how accessible is the steering wheel, how easy is it to get at these knobs, and what kind of a view do I have on all the controls. It adds an awful lot of power to the virtual experience. And where that comes into a lot of value is when you have review of very complex data. That car interior is complex. There's a lot of components in there to review, and it's very spatially compact. Think about trying to design a work cell or a factory or a complex piping assembly or wiring assembly, and being able to see the spatial relationships between the components, being able to interact and navigate naturally, look around things naturally, that if you wanted to see something underneath, you just bend down and look underneath, or you want to look around an object, you just literally move and you can look around something. That has tremendous value to being able to work better. And really there's a compounding benefit to all of this, because a large-scale display where you could look at something in one-to-one scale, and then you're adding 3D stereoscopy to that so you can see the spatial relationships, and then you add motion tracking so you can move around things. It is a compounding benefit. So you say, okay, what are the benefits? And really, there's a few studies done on this, and I pulled out one where it was a review of spatially complex data. People were asked to look at the data, find specific targets, and it was tracked how long did it take to find specific objects, how accurate were they in finding them, and found that when someone had motion tracking on, head tracking on, that they were able to find things faster. They were able to, and it's in terms of this technology, it's called time to insight. So time to that aha moment. If you can get there 50% faster, think of what that could do. If you can shorten your insight time, move things along more quickly, and if you can do it more accurately as well, that just, again, there's potential value there to be tapped. And again, while this is fairly standard in a cave, it is optional to others, but it's something to ask about, how could this help me interpret my data more quickly? So we're going to move on into another important topic, which is the software aspect of this. And the question that we always get is, okay, I have my CAD models, but how do I get those into VR? And really there are three ways to get CAD data of various kinds into a virtual reality space. Actually, some CAD model or some CAD programs have native capability. There are VR plugins available that will go direct from CAD into VR, and then what is happening, or what is coming along very quickly, is going from CAD to game engine to the VR environment, and that sounds like it adds an additional step, but that is smoothing out, and we'll get into that shortly. So native VR capability, and I'm going to reference the picture on the right. That was actually a display that we did at the Smart Manufacturing Conference in March of this year. We set up a 12.5-foot wide power wall. We had motion tracking, put the track glasses on people, and very quickly they were looking at an airplane model inside, outside, pulling pieces apart, engines apart, or they were very quickly navigating around the factory floor and moving components within the factory to see if they could improve workflow. And that was being done natively. Now, many CAD packages will offer 3D stereo capability, but not necessarily VR capability. Again, VR is about creating that sensory experience and adding interactivity. There are an increasing number of CAD packages that are having direct to HMD support, and I think the best thing you can do is talk to your service provider and your ISV and ask about the capabilities that the software offers, because again, there are others with full support for all VR displays that you've seen before. Two examples are Dassault and their 3D Experience and Siemens Teamcenter that we used at the Smart Manufacturing event. Those allow you to go direct from desktop into something like a cave with all that motion tracking capability. It's direct desktop to that VR space without conversion, and that can be quite powerful. But again, talk to your software provider, ask them what current capabilities are, ask them what their roadmap is to find out what VR compatibility they might have. So if your software doesn't have any VR features, there is something you can do called CAD to VR Interception. There are plugins available on the market that you load along with your CAD program. You run your native CAD application, and then the software plugin will add 3D stereo if it's not already there. It will add the motion tracking capabilities. for an HMD potentially, so it will go direct from your desktop into HMD. Keep in mind that many of them are only viewers. All you can look at the geometry of your model, and that's essentially what a VR interceptor is doing, is intercepting the geometry, and then you are looking at a representation. You're not looking at your actual data, you're looking at a representation of your data in the VR space. And some of them will allow you to fly around that or navigate around that, and that's about all you can do. Some plugins will offer some additional functionality where you might be able to do measurements, or it might be able to it might identify some specific meshes and components, and you can start pulling pieces apart. So if you're investigating these VR interceptors, and if you search that, you'll find them. That's what you might be looking for, are those additional tools, and there may be even some collaboration features available or multi-user capabilities available. And then some of these interceptors will go all the way up to caves, and the illustration on the right is basically saying you have your main workstation, and then it's going to separate the geometry or that representation of your model out into the required number of outputs for whatever kind of display that you might have. As an example, a cave, 3 walls and a floor would need 4 outputs. So the plugin is going to do that interception and division into those appropriate screens and viewpoints, and then manage everything from there. Now, game engines are just that. These are the game engines that were developed for creating consumer games, but many of these these game engines are really starting to focus on the enterprise environment because there's so much potential. With game engines, you could start from scratch. You could build your model, your car, your whatever your machine is, using a game engine and building it up from scratch, but we're not going to deal with that. We're really talking about the conversion process. And it is a process to start with your CAD model, and then the game engine or the plugin for it is going to look for things like the common colors. It's going to look for your object hierarchies and your data hierarchies. It's going to look for metadata. It's going to look for common meshes, and things like that would allow you to eventually pull apart things like the wheels or common elements so that you can interact with your model. And why game engines are coming on strong is because it's extending the use of the CAD model into other applications by adding things like photorealism to make an object, or to take your CAD model and make it look much more real. That might be very valuable for marketing purposes, for sales purposes. If you were doing high-level demonstrations and wanted something to look like it was in a realistic environment, outdoors, indoors, you can add those components in. You can do this. The real-time ray tracing is coming on so quickly, where you get the shadows, you get reflections, and it just adds that sense of realism to a product. You can add characters and behaviors to those characters and behaviors to the models and some physics and things. We have a client who wants to model an airport, and they want people going down escalators and bumping into each other and seeing where the choke points are. And so there's a lot of opportunity if you wanted to see what ergonomics are like or reach points are like in a factory model. And again, these game engines were created for consumer gaming and for those head-mounted displays like the Oculus and the others. And I'm sure you're familiar with those two-handed controllers if you have those head-mounted displays. And you want to be able to take that familiar two-handed interface into a more complex environment, and that's possible with some of the methodologies. So as I said before, this is a workflow, and there are conversion tools, whether it comes along with the game engine or a third-party engine. And the goal of those conversion tools is to really optimize geometry to tessellate, make the model as small as possible, while maintaining some accuracy and to the data. And you really want to optimize that. You would need some programming resources potentially to do some scripting to automate those workflows over time. And that is something you may want to hire in-house, or you may want to get a third party to do. And we get asked, well, what is the conversion time? But it really depends on your model complexity. It depends on the details you want. It depends on the interactivity you want and how you want to pull things apart. And that's something, when you get to that level, you want a subject matter expert involved to help you figure out what could be involved in making that conversion. And I have a slide here that highlights one effort to make that conversion as seamless as possible or as invisible as possible, and that is Epic Games with their game engine called Unreal. And they are making a concerted effort to support the enterprise, and I know that the Unity engine is as well, but Epic has developed a product they call Datasmith. In the picture you can see on the right-hand side, I hope you can see it. And I'll read off some of these where SketchUp, 3D Studio Max, SolidWorks, CATIA, Siemens, NX, Creo, and other formats can be imported into Unreal Studio through this Datasmith optimizer. And the goal is to make this as transparent as possible so that you're essentially going direct from your CAD program into the Unreal Engine, which is where all of that real-time rendering is done and where physics are added and where you can start to get into that photorealism. Their goal is to really have proper conversion without any losses. That's a real focus that they have, so that what you have in your CAD model translates into that game engine and you have confidence that it is accurate. And there's even work being done to try and make some of that bidirectional, and that's something I should have said before with some of these VR interceptors, is that is not a bidirectional workflow. You can't, with a VR interceptor or currently with these game engines, work on your model and have that translate back into your original CAD model or your CAD program. You will gain insight by looking at your model in one of these viewers, and then you have to go back to your desktop and make those changes and go back and view it again. Your iterations get faster and faster, but it is not a bidirectional workflow. And again, the focus now is really to make it faster to get your model into those game engines by something like Datasmith, and I know there's PixXY from Unity, and there's a little quote down here you may not be able to read in the slide that says, with Datasmith, I can literally do the same thing I did in weeks now in one day, and that is magic. So these are going to continue to improve, and it's something that we watch closely. Now, I said earlier that once you have something into a game engine, there's still that going to VR, and that's where you get back into whether or not a plugin is required. If you have a head-mounted display, these game engines were designed for gaming, and a big part of gaming these days is the VR headsets and being able to do a virtual game. So there's compatibility already for game engine to head-mounted display. Again, you want to check and see if you're just viewing or if you're able to do interaction, but any of these game engines should go direct to an HMD. There are plugins that will work with these game engines that will take it into more complex VR environments like caves. Some of them will allow you to add the tools like measurement or whatever you think you might need to do, or tools can easily be added. It is extensible, and tools can be built to meet your requirements. But it is a plugin and will behave similarly, where if, let's say, again on the right, your plugin will separate the image out into the necessary viewpoints for a cave or a tiled wall or whatever might happen to be. Thing to note, though, is that there is a move to have native capability or native VR capability with these game engines. So you will be able to go direct from Unreal into a cave, and that's on the horizon, so something else to watch for. Last part about software, and it's really not about the VR part, but once you have something in VR, I mentioned being able to do collaboration before, and with these environments, there's a lot of local collaboration you can do with your teams, but we also get asked about remote collaboration. And absolutely, there's people who want to connect from one office to another office, one city to another city, one city to another country. And yes, that's absolutely possible. HMD to HMD is being done. HMD to other displays like a power wall or a cave, also possible. The image that's on the right, and these are pictures that we took of a demonstration at the Rave Cave in Michigan, and that space has a four-wall cave. It has an angled power wall, and it has Oculus Rift, and all of those were combined into one shared workspace. They were connected so that each viewer, regardless of which device they had a pointer. They were looking at a common model. They were able to, point things out to their counterparts. And that was a local demonstration, but showed how we could connect different displays. When you think about even local, but you think more about going remote, you want to start looking at the network connectivity, because the biggest thing to look for here is, you want to avoid is the lag time. That if someone in Detroit wants to show something and they point, that pointer shouldn't show up 5 minutes later over in Europe. And there's a lot of factors that go into affecting the latency and the bandwidth requirements, and that's really where you need a subject matter expert to look at the types of displays. You want to look at the software that you have. You want to look at, this says what tools are available, but what I mean by that is, what tools will you employ? Are you simply going to be viewing something, or are you going to be pulling objects apart? Will you have full motion tracking on, like in a cave? And how does that motion find its way? How active are the participants going to be? Again, are they just viewing, or are they going to be moving around the space? And all of those viewpoints need to translate smoothly from one location to another. So all of that, all of those interactivity and display parameters have to be considered when you're looking at the network, and that's all part of a consultation process. So we'll get into the computing requirements because, again, it is scalable or will change with the different displays you have, and the variables are really what have to be taken into account here. And the first thing would be your application. What does your application offer? How is it something like a standard basic CAD program, or you're looking at something like a VRED where you're trying to do more photorealistic representation? What's the complexity of your data set? Are you looking at a single machine, or are you looking at a model of multiple machines in a very complex factory setup, and you want to be moving things around, and you're looking at a large facility? The display fidelity, I mentioned fidelity before, the resolution, the number of display elements, the photorealism, the use cases, whether or not you have motion tracking, because adding motion tracking adds some burden onto the compute as well. And what we're calling this is the complete video topology. And by that I mean, it's not just the number of outputs, it's the number of display elements, it's the number of GPUs, it's the number of computers even that would be required. The picture on the right is actually of a 96 output, or a 96 node cluster that was built for a 100 million pixel display, and that was a lot of graphics compute that went into that. When you, depending upon the display you have, compute requirements can be simple, they can be difficult. For HMDs and potentially a single power wall, it could be a single graphics card, a game level, or an advanced level. Again, it depends on your model, your fidelity, other things you want to do. You'll see in the news, or in articles, VR-ready graphics. And I just pulled a snip of an article, best graphics cards for VR. And a lot of those are intended for that single viewpoint, head-mounted display, or maybe some other form of simplistic display. And they've been designed for those particular use cases or those particular display types. When a display gets more complex, you start getting up into a cave as an example. One graphics card might be able to do it with 4 outputs, but you start getting into even higher resolution, more pixel caves, more pixels, and I mentioned a 100 million pixel display. That's a whole other level of computing. Tiled walls, you start to get into something called mosaic mode, where you have to stretch a desktop across multiple displays. You have to sync all those displays so that all the images are together across those multiple display elements. Stereo motion tracking adds a separate computer because you're tracking the person and then adding that back into the virtual scene. And you want to even look at processor speed, and we always say a faster single processor is better than multiple slow processors because everything goes to the lowest common denominator. One single slow processor is going to slow everything down. Again, it takes an expert to really look at the application and bring all this together. So we looked at the display types, we looked at computes, and so now we want to look at some of the use cases and some of the ways people have realized value from this technology. And the first slide in this, and this I showed in the previous presentation, but I wanted to put it up again just to show all the different areas where VR, and in this instance I decided to include AR because again I think the two can coexist, says that VR has a lot of value across the enterprise in all of these different areas. If you've taken a screen capture and want to see all these, or if you want to see the recording, you'll be able to see all these. I don't want to spend a lot of time on it, but other than to say there's a lot of opportunity. Now, as I went looking for use cases in the prior webinar, we actually covered quite a few use cases, and I didn't want to repeat those. And I thought, well, if someone's trying to build a business case, they might want to know what else is out there in the press or other applications. And honestly, not every one of our clients wants to provide details about their work or their returns. That's private information to them. So I went out and I looked and did more research on some of the use cases and articles, and I pulled 3 of them here. Again, you can simply search these titles and you'll find these articles, or we can provide the links to you. And I'm going to dive into a couple of them just to show what these results are. And this was an interesting one that I found. It was actually a study done by Iowa State University on behalf of an industrial client where they looked at welding training and what kind of value would VR add to teaching people how to do welding techniques. Instead of using real equipment, put it into VR. And you can see all of the gains that were made. They published it into this simple infographic. And this was actually done in 2010. So this is something that's, again, was realized quite a while ago what the potential for the technology is. And also want to point out that the universities can be a great place to try your data or to have trials done and work together to see what value it adds to your particular part of your workflow. But the benefits in decreases in training time and accuracy and even cost showed that there was value in doing this. This was done with head-mounted display and real equipment, but really engaged the students and generated some tremendous results. This one also happened to be done at Iowa State University. I didn't realize that until after I'd read both. They were done at different times. But this was a session done in a cave where they invited a company that built hydraulics that never had experience with virtual reality. These people had about 7 years of CAD knowledge, CAD experience, and they'd had no experience with caves or VR of any kind. So they wanted to know what it would be like to work with their models in a VR space. They did 3 sessions in a cave. In the first one, it was really about seeing their models at 1-to-1 scale for the first time, but also seeing it in 3D so they could see the spatial relationships between very densely packed components. And while not quantitative, they had to admit that they were able to achieve insight much, much faster. As I said before, time to insight was reduced, and that had value to them. So then about a month later, they go back in and they said, okay, we have our model settled, but let's look at the assembly process. What's it going to be like to actually build this? Will people have the access that they need to do this efficiently? What's the procedure going to be like? And in that 90-minute session, they were able to work through many more iterations and make changes to how the components might fit or access points and the procedure of assembling it. And then in the final one, okay, we've decided what this is, but what is the work cell going to look like where we actually build this, and what's the entire assembly line going to look like and the factory going to look like? And that's where, as they got more used to the technology and the wow factor went away and it just became a familiar working environment, that's where collaboration really started to kick in, and they were able to share the data naturally. They got to that insight. They realized that the collaboration they were doing in the cave was much more valuable than any meetings that they had at their office with just standard monitors and CAD. And they made significant design changes as a result of their time in the cave, and that ultimately saved money and time in the final realization of the product. Raytheon is one other example, and Raytheon is a case where the company has made iterative investments and ever larger, I'll say, investments in VR because of the value realized. They've had VR for years, starting with smaller displays, and have worked up to some customized displays for their requirements, and have developed this, what they call the design to manufacture workflow. And some of this is from an article that they've published about working with a design of one of their products where the wiring harnesses were incredibly complex, and it took 500 pages to really document the complexity of all these wiring components. And they decided that they would translate all of that into CAD and then call in the supplier who would be doing some of these assemblies, and the installers who would be putting all this together, and get their feedback on how could this be improved, how could this be made different. And they ended up changing the design entirely. And originally, and based on prior projects, this was seen to be an 18-month design cycle to get from initial to final decisions, and they reduced that by 8 months, and that's significant because you can move on to other projects, you can do other things, and they brought it in 40% under budget. Tremendous savings, and realized the return on this particular system much, much more sooner than they originally anticipated. And then I talked before about having multiple applications in the same display to increase utilization, and they used the same system for facility design. And in this instance, they were building a new factory, brought in the model of the factory, found, quote, hundreds of issues, and that ranged from, there should be better signage here, to this door is in the middle of the floor, who knows what it is. But they went through 57 design iterations before construction. They acted upon 49 major issues found, and they calculated that they avoided $1.5 million in construction changes. So if they had started construction without having found these in advance, it would have cost $1.5 million more to make those changes later on. So cost avoidance is another way to measure ROI. So we're nearing the end of our time to be able to get into our Q&A session. And to end off the ROI section of this, really ROI is very, I'm going to say, personal to every organization. And I wanted to put in some thought starters here on what it may mean to you. It's, okay, that worked for that hydraulic company or worked for Raytheon, but here's what I'm dealing with. So think about, what is the cost of a physical prototype for you if you build them? We talk with people who are doing work cells with cardboard and plywood, and there's time to do that, and then there's time to change over to the next prototype. And then what does it cost if you didn't do any prototyping, if you didn't do any virtual prototyping, and you realize an error later on, what does it cost to fix that design error once you've gone into manufacturing? What is the value of reducing time? What is the value of avoiding cost? What is the value of your user's time? What is the value of an engineer per hour? And if you could save their time, what else could they be working on? And the last one is looking at it potentially from a sales aspect. If you were to extend the use of your virtual models and show them to clients, use them for marketing purposes, but what's the value of a new client making a new sale? An example we used in the last webinar was Genesis Systems, who uses their system for design, but they also use it for sales, and will adamantly say that they realized tens of millions of dollars in sales as a result of being able to show their data differently in a VR space. Oh, and also those ROI thought starters are available. And I'm just going to go back to that slide for a second. Those ROI thought starters and some very brief use cases and other information are available in a document that we have on ROI in virtual reality. And at the end of the webinar, if you want to provide feedback, please, and request that document, we can send it to you. So I'm going to, before we get into questions, and actually I have one more poll, really want to get to what's important here. And I've shown you a bunch of technology. We've talked about compute. We've talked about everything else. But I've mentioned that there are subject matter experts in these areas. And it's always important to start with your objectives in mind. What process are you trying to improve? What are you trying to achieve? And from there, the use cases are going to dictate what technology should be applied to help you achieve those objectives. We don't start with technology first. We start with what you're trying to do. Multiple applications, I'm going to say it again, can increase utilization and return on investment. And that's just, again, it all factors into what type of display. And then if you are building a business case, you're investigating this technology, consider the resources required to have a facility like this or a display like this, not just the initial investment, but also in the long term, whether you can do it all in-house, whether you have to recruit, whether you need third-party assistance, and also not just in year one, but the following years where the system has to be operated, maintained, upgraded. Those are all very important things to take into account. So finally, I'm very curious, based on the information that you received so far, where do you think VR might have value in your organization? And this is just wondering thoughts that you have about where you might start or where you're already working. And I'm just going to give a moment for people to skip to input, and then I'll skip to results, and then we'll head into Q&A. And I am going to press skip to results. Training and service, product design, absolutely. These are all great. Thank you for those to those people who answered. And with that, we will move on to questions. As I said, if I can't answer a question, I will get you connected with someone who can.
Great, thanks, Jeff. So we do have one question. It kind of has three parts. So what is your take on the differences between a Cave versus a Cave 2 system? Is a Cave 2 typically cheaper? Which is better in your opinion?
So Cave and a Cave 2, and for those who aren't familiar with the terminology, Cave is that, I showed them earlier, that is a 2, 3, 4 to 6-sided virtual reality space where you're typically viewing things at 1-to-1 scale. They are typically projected, and a Cave 2 is one of those tiled displays where we're using multiple LCD elements, and a Cave 2 is actually 18 columns of displays arranged in a 320-degree cylindrical fashion. Both surround or fill your field of view with virtual imagery. Both will allow you to view in 1-to-1 scale. Both are motion tracked or can be motion tracked. The difference is that a Cave 2 typically does not have a floor. And whether or not you need a floor for your virtual model is dependent on your application. Do you need to see what's at your feet? Do you need that visual reference for your sense of presence? Also, a Cave 2, because I said it's made up of 18 different columns of panels, and it's 4 panels high, so that's 72 panels of HD information, 72 million pixels. That is much higher resolution than the typical Cave on the marketplace. And with that comes higher associated costs. So I'm going to say yes, a Cave 2 is more costly than a typical Cave. And again, we want to look at which is better is going to be based on your use cases. What is the data you're looking at? A Cave 2 has I'll say an advantage of a portion. I mentioned the 18 columns. A portion of those columns could be 3D stereoscopic, while the others are 2D information, and that's actually how some clients use them, so that they can be viewing a 3D model on one side of the display and viewing bill of materials and design plans and everything on the other part of the display, and it becomes a very powerful working environment. Which one is better depends on your use case.
Great, thanks, Jeff. We do have another question. Do you have or know of any cases with mixed reality? This could be real objects in space and VR or AR together.
I'm starting to see more examples of mixed reality. I honestly can't think of one off the top of my head. I've tried many of the head-mounted display or the head-mounted options, the HoloLens, the DAQRI, and use them. So yes, I'd say I've experienced them. I'd want to know what you're thinking of and what you're considering using it for, or what the advantage might be. So maybe that's a conversation we can take offline.
All right. Where do you suggest someone starts when implementing a digital initiative?
I'm going to go back to the last slide that I had that said it really all starts with your goals and where you think you can make improvements. So looking at your workflow, where do you see that you could cut costs, reduce time, make improvements in design, and think about how VR might help that. You may want to do a pilot run using a head-mounted display just to even experience your data in 3D for the first time, or get a sense of whether or not you get greater insight by being able to move around it. You might consider working with a university who already has some of the technology and testing some of your data there. But really, again, it all starts with where you think you can make gains in your workflow.
Alrighty. Next question. Curious how much bandwidth this technology consumes. This person completes virtual reality training and has some bandwidth issues at times, and they're curious to know how this could potentially be a risk for training.
That's one of those questions where I would like to defer to a subject matter expert who will ask you questions about your setup, what components you have, what your existing network is like, and that one I think would be better answered by one of our compute and software experts. I would say, could it have an impact on training? I would think yes. That especially if someone is experiencing latency or lag from the time they're doing a task, let's say an assembly task, and the time they move their hand to the time that the image actually moves or changes, that's very disconcerting. Or maybe you're trying to share remotely, I don't know, but certainly would like to connect you with someone who could ask more about your setup.
Thank you. I have another one here. I've noticed that in many of your images, people are wearing a headset with a screen in the background. Is the screen purely for those observing the VR session who are not wearing a headset?
In many instances, yes. And I touched on that briefly in one of the slides, but I know I said it quickly, is that I see it where the person wearing the head-mounted display, again, is controlling the viewpoint. They might have the most intimate knowledge of the design. They see the value or know the value of being able to navigate through it or walk around it using a VR device, but they want others to see that data the same way. So whether that display is in the larger scale display for the team is in 2D, and we see that in the others are watching in 3D as well, then yes, that person wearing the HMD is controlling the viewpoint, but wants to be able to share that with the team for collaborative purposes. But it may also be that the person wearing the HMD is connected to a wall system in another city or another country, so it could be for collaboration that way.
All right, and last question before we wrap things up. Do you have any case studies on how VR has been used effectively to reduce product manufacturing assembly processes?
Off the top, I'm aware of a couple. I can't cite them right now, but I will locate them. please provide your information and we will share what we can.
Awesome. So with that, thank you everyone for attending. I've gotten a couple questions about will this recording be available? Will the presentation be available? We will be sending out an email tomorrow with the recording link. And since we've gotten quite a few requests for the presentation by itself, I will also send that out as a PDF. I would appreciate if you would take some time to fill out the survey. You will be getting that at the conclusion of this presentation. And if you have any follow-up questions, there is a section for you to submit those, and we will follow up with you on that. But other than that, thank you all for attending, and we hope you have a great day.
And thank you all.